The next question. CH3, C double bond O, CH2, CH2 taken twice, COOET. So one esteric group we have and one ketonic group we have. So this keto substituted ester on treatment with sodium ethoxide, that too in excess, then followed by CH3I. The major part of the reaction is what? If it is shown by X, then which one the following corresponds to X? So in this reaction, CH3C double bond O, this is the polar group, and CH2, which will be write it as this way, and this CH2 twice, and then we have CH2C double bond O, OET. And here we are using what is called RONA, that is sodium alkoxide, alkyl group being ethyl. So this ETO minus is a strong base, RO minus, and this RO minus, when attacks here H, we get the carbanion. What about these hydrogens? This particular hydrogen is more acidic than these three hydrogens. Therefore, this ETO minus ethoxide ion attacks this hydrogen to give the corresponding carbanion. So CH3, C double bond O, CH minus, and this CH2 twice, and then this CH2, C double bond O, OET. And this carbanion now will attack this carbonyl carbon of the ester to give what? Thus we get C double bond O, CH3, and here is the 5-membered ring. Here we have OET and O minus. So in the next step, this will shift here and the OET, that is ethoxide ion, will come out, and thereby we get this C double bond O, CH3, and this is double bond O. And this in the next step is allowed to react with methyl iodide, but we have in the presence of a base, once again E2O minus. This acts as a base and attack the acidic hydrogen. So here are the alpha hydrogens we have to this ketonic group. Here also we have one hydrogen which is in the alpha position to this particular carbon as well as this carbon, and therefore this particular hydrogen is more acidic than the hydrogens here So therefore this H will be replaced when we treat it with methyl iodide in the next step. So thereby the product of the reaction now becomes, this part will remain same, and here is the C double bond O, CH3 as it is, and here one methyl group is substituted. So thus the product of the reaction is this. Now when we observe the answers, this is a 1, 2, 3, 4, 5, 6, 7-membered ring is formed, and the remaining are all 5-membered rings. And we have here in the D, we have OH and OET, and now we need to compare. So we have here in the B option C double bond O, CH3, that is the acetyl group, and methyl group in this position. But here it is the OET that is given. So it is the methyl group. Therefore B is the right answer.